Okay, so this is Mr. Trolson again, and we're on day 2 of section 8.2, trigonometry. And today what we're going to do is we're going to be learning how to find a missing angle by using SOHCAHTOA, using sine, cosine, and tangent. So as you recall, memory device SOHCAHTOA means the sine is the opposite over the hypotenuse, the cosine is the adjacent over the hypotenuse, and the tangent is the opposite over the adjacent. And I found that when I'm making these videos that sometimes the sound gets out of sync with what's going on, so I'm going to try and be a little bit more deliberate and try and solve that problem, but hopefully it will be okay. We'll see. Anyway, solving for a missing angle, this is the inverse trig. And so when you do an inverse trig, or you're doing any kind of inverse, as you recall, it's when you take the input and the output and you switch them. So in this case, let's look at this one down here. We want to find how big this angle A is. And we have to work with, we have the hypotenuse and the opposite. So in SOHCAHTOA, it's the opposite of the hypotenuse is sine. So we can say that the sine of angle A is equal to the opposite over the hypotenuse. Okay, and then the input in this case is A, and the output is 54/64. We want to switch those and write it, and the way we write the inverse sign is we say the sine to the -1. Looks like an exponent. You don't say the sine to the -1. You say the inverse sign, and then we switch these two, input and output. And then we solved it. So in your calculator, if you go to second sine and then put in 54/64, then it will give you how many degrees A is. And so if you do that, you're going to find that angle A is equal to 56.18 degrees. And remember to be in degree mode, and the way you can check is just do sine of 30, like sine of 30 degrees, and you should get 0.5, because a sine of 30 degrees is 1/2. If you're in a radian mode or a gradient mode, there's different modes, then you're not going to get 1/2, and you need to figure out in your calculator how to change it over to degree mode. We're talking about degrees. Okay, let's look at this one over here. Here we have angle A. We're trying to figure out angle A, and we're going to use the inverse sign. You can see that this is a isosceles triangle. We can say off the bat, I can tell you right away that this is going to be 45 degrees, because if this is an isosceles triangle, that means that whatever this angle is, that's what this angle is. And in that case, and I have 90, and 45 and 45 is 180 degrees. But if you didn't know that, you didn't spot that right away, we could write it as, in this case, we have the opposite and the adjacent. So the opposite and adjacent in SOHCAHTOA is tangent. And so we can say the tangent of angle A is equal to 14/14, which is the same thing as 1, isn't it? So if we do the inverse tangent and swap the input and the output of 14/14, or just 1, it's the same thing, that's going to tell you what angle A is. And in your calculator, if you did that, you would find out that angle A is equal to 45 degrees. Okay, so far so good, right? Okay, here we have another triangle, and we're trying to find angle A. And in this case, we don't have the opposite. We have the adjacent and the hypotenuse. So we go up to SOHCAHTOA, adjacent hypotenuse is cosine. So we can say that the cosine of angle A, actually I shouldn't write it cosine. The cosine of A is the adjacent 24 over the hypotenuse 25. Therefore, the inverse cosine of 24/25 is equal to angle A. Again, we swap the input and the output, and now if you do this in your calculator, you'll find out that angle A is equal to 16.26 degrees. So check that out. Make sure that that when you're doing this in your calculator, you get these answers. These are the correct answers. Okay, then the rest of this packet has a bunch of problems that I want you to work as an assignment, but I'm going to do the next two as a just as an example, and then I want you to finish off the rest of them on your own. So trigonometry is really, really useful for applications, because remember, with trigonometry, you can find out angles if you know sides, or you can find out sides if you know angles, and this is really super helpful. So we have a 45 foot ramp leading to a building, forms an angle with the ground of 9 degrees. So the angle with the ground is called the angle of elevation. So I'm drawing the ground here. And now I'm going to draw a 45-degree ramp. And I don't know how close that is, but I'm going to call it 45 degrees. And then, I take that back. I'm sorry, it's not 45 degrees. It's 45 feet long, isn't it? So that means that it's 9 degrees. So let's see here. 9 degrees makes an angle of 9 degrees with the ground. That's not a very big angle. It's not a very steep ramp, which is probably good. So that's 9 degrees. And it's 45 feet long. That's 45 feet. And so they want to know what's the height that the ramp will reach. So that's when it'll get up here and there will be this platform. This is what we want to know. We want to know h. What's the height? By the way, this is called, if you have an angle that goes from horizontal up, this is called the angle of elevation. If you have an angle that goes down from a horizontal, that's called the angle of depression. So you can remember this is the angle of depression because it's like the trapdoor on the gallows of a hangman, right? That's kind of depressing, right? That swings down when the guy gets hung. Anyway, yeah, you've seen enough movies for that. Okay, so we want to figure out how high this is. So we've got this angle, and we've got the opposite side and the hypotenuse of this right triangle, because this goes straight up. This is an altitude right here. And so we can say that the sine of 9 degrees equals the opposite, h, over the ramp length, which is 45, hypotenuse 45. So this isn't an inverse. We were not trying to find the angle. We know the angle, and what we were trying to find out is this side length. So this is just straightforward sine problem, because it's the opposite over the hypotenuse, and so we're going to multiply both sides by 45, and we get the height. And so the height should be 7.04 feet. Okay, it says for the same ramp, how far away from the base of the building does a ramp extend? Okay, so that would be this distance from here to here. Let's call that x. This distance that goes from here to here. That's how far away from the building the ramp extends. This is the building right here. So we can say that this is to this angle 9, which is what we know, we can say that this is the adjacent and that's the hypotenuse. And looking at our SOHCAHTOA, adjacent and hypotenuse is cosine, so we can say that the cosine of angle 9 degrees is equal to x, which is the adjacent, over the hypotenuse, which is 45. So we have 45 times the cosine of 9 equals x. And in your calculator, you'd find out that x is 44.45 feet. Okay, so draw pictures whenever you need it. Always draw a picture. And then you can find out if it makes sense. Yeah, so do your best on the rest of this packet here. Draw pictures for the applications, And yeah, when you're done, email me and let me know how you've done. And if you can, scan it and send it to me, okay? I put online the answers to this whole thing. And so if you go to 8-2, day 2, trigonometry, you'll see that I've got the answers in there. So check your answers, but do as much as you can on your own, okay? Right, so signing off, and I'll be talking to you for the next lesson.